Alright guys, so welcome back to the Hello World Guy, and in this video we are going to finally get started on our new game. So if you remember, then we are completed our FPS game, everything in the last video. So now we can finally start a new game, and this is going to be a course to get you familiar with some 2D platformer basics, because that's, believe me, really important. And yeah, let's quickly get started. So here I've opened up Unity Hub, and this is the new version. That's the reason it looks kind of different. I didn't, when we made the FPS and the Pong game, we did not have. I used the previous version, so it's just a little bit of UI change, nothing, too much. So just hit on new project, and it should get all the templates here. So just choose 2D, nothing, not 2D URP. You can do that, but that's just complicated. Just choose 2D, and now for the project name, I'm going to just call it platformer, and then just go ahead and hit create project. So here I've got my Unity scene here, and I just done nothing. I have changed the background color of the camera to be this kind of color, grayish, so that it just feels better for me. You can make it something like a sky if you want, like that, I guess. Yeah, you can have it as a sky, but I'm going to leave it at the old color, this grayish color. And now what I'm going to do is, well, let's get started with our game. So I'm going to start with adding a square here. This is going to represent our ground. We will add a proper tile map level editor later, but for now, not really. Minus 4.5. Then I'm going to increase its by scale to something like 3, and its x scale to something like 50, and its z doesn't really matter. I mean, we are working in 2D, come on. And I'm going to make it a grassy kind of color like that, and then I'm going to add in a box collider to this. No, box collider 2D I meant. Don't have that 3D collider, it causes a lot of problems. Anyway, so now for the player, I'm going to just right click here and create an empty object called player, and I'm going to move it to 0, 2, and 0. Z is not 0 right now, so just make it 0. I'm going to right click on this player object and add in a 2D sprite square here, and I'm going to call this sprite, and then I am going to make it 2 on the Y, and then I'm going to just increase its total scale down a bit, like that, and then I'm going to make it 1 on the Z. I'm going to change its color to be blue. That looks awesome. Maybe not blue, red. Yeah, that, no, not very green. You can make it whatever, like I'm just making it that this kind of color. And I'm going to right click on the player again and add yet another sprite here, and I'm going to make this one black, and then I'm going to increase its decrease its Y size and decrease the X a bit as well. So I'm going to decrease the X to something like that, and then decrease the Y. This is actually going to represent our player's direction, like that. Actually, the black color doesn't really stand out with the background. Maybe making it white would make more sense. We just stick with black. Alright, that looks pretty awesome, I guess. So yeah, this is our player here, and of course I'm going to select my sprite and maybe add in a box collider 2D to this. Or if you don't want that, you can add a box collider 2D to the player itself. And if I go into my scene view, hit F, you can see that I can actually change its scale to match that of the actual collider. So I am going to increase its scale so that I actually want this to match the sunglasses as well. So I'm going to move this to the left and increase its X a little bit more, decrease, and then you can just play around with the offset and the size variables here to adjust it to something you like. 0.17. Alright, and then for the X, if I go for 1, then you can see that it kind of doesn't work that much, but if I go for 1.1, I think that should be nice. Let's try. No, 1.2. And then make this 1.5, 1.6 maybe. 1.2 is a bit too much, as you can see. You might want to decrease it, but I'm going to just leave a little bit of space at both ends. Just that. Yeah, that I think is pretty good. And then I'm going to of course increase its Y to actually cover the whole player, because it's currently not doing that. maybe set it to 1.8. Not really, 1.75. 76. I think, just want exact something. You can set it whatever you like. Anyways, after doing that, I'm going to select the player and add in a rigid body 2D component, and then I am going to go under constraints and freeze its rotation. And now if I hit play, then you should see that the player is definitely working and it falls down. So the square sprite is currently I'm just going to increase its ordering layer to 1 for now. Not going to create a separate layer. I just create the ordering layer to 1, and now this will work. So yeah, that's pretty awesome. So now we need to actually get started on the player movement. Alright, so in order to add a player movement, I'm not going to do anything too complicated. I'm going to right click here and create a new folder. Just call it scripts, just following the kind of previous project structure. I'm going to right click here and create a C# script. Now I'm going to call this one player, just player. I'm going to put all my player logic in one script, even though it should be in different scripts, because we have got a couple of different a lot of things, and this will grow large, but we will think about that later. So as soon as this script opens up, what I'm going to do is first of all remove those two tags. Now here what we are going to do is something really simple. We are going to, of course, now it's a good idea, because we will be using the rigid body for moving. So it's a good idea to say that this component requires the rigid body component, rigid body 2D, by the way. And in here what I'm going to do is create a rigid body 2D called let's call it RB, because come on. And now I'm going to, of course, this is going to be a private. I just kind of like to have private and public, explicitly, uh, even though that wasn't really necessary. So in the start method, we are going to say RB is equal to get. Now we can be sure that it will never fail, because the rigid body, we are saying that it should be present here, and it will not run unless we provide it with the rigid body 2D. Now in this update method, we are going to actually update it in here, and we could do it in fixed update. Actually, that would be better, but we are actually going to take the input in here and then set it in fixed update. But yeah, we'll get to that in a second. So first of all, the first thing we will do is I will create a float called the input, and set that to input dot get axis, and axis name being horizontal. Okay, so this should provide us with that axis, and what we are going to do with this is that we are going to basically set our BGG body's velocity depending on this input. So for that, what I'm going to do is just do a couple of things. Just add in a serialized field here, a private load speed, by default being I'll just make it something like 2. You can change it later, of course. Something like 5 would make more sense though. Even though it should have set itself automatically. Alright, now in here what we are going to do is we are going to not set the RB velocity here, because that is going to be done in the fixed update. Instead, we will create a variable here, a private float called move. And in here we will just take our input, and actually we don't need to do that. We can just set our move directly here. So just set move is equal to input dot get axis multiplied by speed multiplied by time dot delta time. Oh, actually no, we don't need to do that, because this is setting the rigid body. So now I'm going to add the fixed update here, fixed update function. And in here what we are going to do is say rb dot I'm actually going to create a vector 3 called actually vector 2 called velocity. Let's call it short, and then set that to rb dot velocity, and then set its x is equal to our move variable, and then set rb dot velocity to that velocity, because we cannot change the properties of this variable directly. Now this should at the basic level work, function pretty well. So if I go under Unity and I hit play, no, it's not perfect, I hope, but I hope it works at least. Actually we haven't added that component, so it can't really work. So I'm going to just add it here, and come on, add it here. below. Alright, and now if I hit play, hopefully this will work. uh, okay, you can see that it's working. It's still a bit smoothed out. It's not like exactly, snappy. It feels like kind of sliding the player, but the basics are working. So the reason that this is exactly not functioning is that, so if I'm just to show you, our if in my script you can see that we are setting the velocity directly, so it can't be possible that the rigid body is smoothing it out. Actually our input is being smoothed out. That's what being smoothed out. And so if I go under Unity back again, I'm going to go under file, edit, and then project settings. And if I go under input manager and go under axes and then go under horizontal, then you can see that if I go under gravity, it's 3. Now if I just, for example, change that to 1000. So if I go under fire one, you can see that its gravity and sensitivity both are set to 1000. Now if I do that, then our movement should immediately turn snappy because our keys are being smoothed out, not the actual movement. So you can see that now as soon as I leave the mouse, the player stops. So it's very snappy. Now with that, it is possible to smooth the movement a little bit if you want that. They actually like this kind of movement, so I'm not going to do that. Now now that we have got the movement working, the next thing to add is jumping, and this is where things are a bit complicated. But well, what I'm going to do is go under Visual Studio here, and in the big function we are going to do something really simple. We are going to say if input dot get button down, and for the button name I'm going to say jump. So if you get that button down, then we are going to say rb dot add force, and then for the force I'm going to say we are going to say a new vector 2 with I'm going to just set it 0 0 for now. Actually, let's just do it. Go up here, add in a serialized field here called a private float called jump force. Right, so after setting a jump force by to default 5, I am going to go under here and add the jump force here. And I think maybe change it. Alright, I will not. We'll change it in inspector now. So if I go under Unity, we can hit play and test out what our actual it looks like. Actually, one thing. Alright. So yeah, I just changed the mask. So it's now 1. It was before 10. Okay, so if I hit spacebar, nothing is happening at all. At all, come on, like nothing, absolutely. So if I go under here again, then why is nothing happening? We are adding the force here and everything is here, so it should be working. Why isn't it? Now the reason is pretty much obvious. Our jump force is way too low, but I would not want like to change it here, and have to do it because I would like think in terms of lower forces and then like do the complicated stuff later. So I'm just going to multiply the jump force by 100. So now this should work, hopefully. So if I let it compile and then I go to Unity and I hit play, then this should actually make our player jump. And as you can see, our player jumps, but we can make him jump again and again in the air, which is obviously not something we want. You can see he jumps once and he should only jump once. He should not jump again. So yeah, now we're going to get to the most difficult thing of a character controller. Not the most difficult, but it's quite difficult, and that is ground checking. So how are we going to do that? Well, first of all, I have added this variable called is grounded, and we are checking it in here. And currently it's just false. We are not setting it anywhere. We'll do that in a second. And the second thing is that I have added a transform here, serialized field called feet, which will represent the transform of the actual player's field by default now. And alright, what we will do here is in order to actually check, we are going to use something called a sphere overlap. It will basically check if a particular we will give it a point and then a radius, and if it will check if any object is colliding with that, and if it is, then that would be, you know, kind of correct. That would mean that our player is grounded. For this though to work, we will need to use a I'm going to we will use a layer mask to determine which things we can actually jump off. Now I actually wanted to do that, but I decided not to, because I think that we should allow the player to jump off anywhere except the player itself, because you know, when we overlap it will also detect the player. So as long as it doesn't detect that, then this should work. So what I'm going to do here is go under here, and I'm going to create I'm going to have an array of collider 2Ds called colliders, and then I'm going to set this equal to a function of class face 2D called overlap circle all. This returns an array. We will give it a point, which will be our feed code position, and for the radius we will give it something like 0.2. We could make it a serialized field. I'm not gonna do that, and this should work. So now what I'm going to do is actually we can do something. We can do a bunch of things, to be honest. So if I open up this, we can see that it has got option in which it takes a layer mask. But as I said before, I want the player to be able to jump off anything. So I am going to not use that method. Instead, what I'm going to do is we are going to do for each collider to the collider in colliders. We are going to say if collider dot compare tag player, and actually this should be not. This means that because you know the circle might collide with the player, and that might register a ground check. So if that is the case, which means that that is happening, then we are going to set if grounded is equal to true. Now if this doesn't work, then we will just set if grounded to false. So by default we will set if grounded is equal to false. Now this should actually work. So we will first compare the tag with player, and if that is not the case, then only then we will set if grounded to true, and yeah, this pretty much should work. So I'm going to go under not this unity, and then in here you can see that I got my player, and I have already created a feed transform here, which if you look at the circle I have placed here, and here the feed of the player at you know, this position, and I have selected that as the feed transform here. So now if I hit play, then this should not work, because currently our player is not tagged as player. So tag it as player, and I'm going to select all objects and tag them as player as well, sub objects. Now hitting play should hopefully work. So yeah, as you can see I can jump on the ground, but I cannot jump if I'm not on the ground, which makes total sense. That's awesome. I'm going to select my player and increase its you know, I'm going to increase the speed here. So just go under here, I'm going to increase the speed to something like 8 or 7.5, and now we should have a pretty great character controller, to be honest. So yeah, that looks pretty awesome. So one thing we left to do is that our player is currently not facing the direction he's moving. So yeah, only that is left now. So that is actually really easy to do. All we need to do here is we need to go here and we need to check if our move is greater than 0, which means that we are moving towards the right. If that is the case, and just note that, and our move is oh, not move, sorry, our local scale. So if I go under and say transform dot scale, local scale, maybe local scale dot x dot x is less than 0, which means that it's negative, which means that our player is flipped currently, its scale is, you know, flipped. And if that is the case, which means that the player is flipped towards the left and we are moving right, then we need to say transform dot local scale dot x multiplied by -1, multiplied, not added. And oh, that doesn't really work. I'll actually create a different function for it. So I'm going to create a void here called flip, just so we don't have to write too much code here. Actually, we don't really need that function, so yeah, just let's avoid it. Anyways, what we are going to do here is, let me add this like that. Then and you can hit Alt to move lines up and down in Visual Studio. And in here, what we are going to do is I'm going to cut this whole area, and I'm going to set. So I'm going to go here and create a vector 3 called scale, and then set that to this. Then go scale, and then paste that we had, and then we are going to say transform the local scale is equal to scale. Now we want to do it in this case, and we want to do it in another case as well, and which is that we are moving left and our player is facing right, we need to flip him. So for that, I'm going to add in an or condition here. No, yes, like that. And yeah, this will work. So I'm going to flip the signs here, and this should pretty much function all right. So now if I let it compile, and then when I go in Unity, it should hopefully work. So I hope you've got what we are doing. If our move is greater than 0, we are moving right, and our player is looking left, then we flip him. And if our player is moving towards the left and he is looking right, then we also flip him. So yeah, this is just some very simple logic, and as soon as the game starts, you should see that if I move this way, it moves this way, and yeah, that's working. So this is pretty much it for this video. We have got a pretty much working system, and we cannot jump in the air, we can only jump in the ground, and this is all pretty good. So yeah, this is it for this video, and make sure to like and subscribe, because a lot of you aren't subscribed. So yeah, subscribe and also like the video, and I will see you in the next video, so stay tuned for that.